Hello everyone, this is Atreya and welcome to our channel CodeChef. Today we'll be solving the problem team formation for Snackdown. Let's get started. Here in this problem statement, it is written that we have n people who want to take part in Snackdown. In the competition, a team should consist of exactly 2 people as opposed to the real contest where single member teams are allowed. So for the purpose of this problem statement, we must understand that in order to participate in Snackdown, you need to have a team consisting of exactly 2 people. Okay. Now, of course, a person can only participate in a single team. That's obvious. Now, out of these 2m people have already formed their teams. That is, there are m teams that are already formed. The remaining people want to participate and make teams among themselves. Can you tell whether it is possible to divide them into teams so that all n people can participate in the event? Let's make this absolutely clear with the sample case. Here in the sample case, we have 4 sample cases. So each test case, we have 4 test cases, and now each test case in the first line consists of n and m. Now n is equal to 2, denoting that there are 2 people who want to participate in the event, but m pairs have already been formed. M equal to 1 means that 1 and 2 persons have already formed a team among themselves. So 1 and 2 are a team. How many total number of people are there? 2 total number of people are there. So obviously it is possible to divide the remaining people so that they can form teams, because how many people are remaining? Remember now, if you look at the problem statement, it is written that 2m people have already formed teams and totally n people are there. So what is the remaining? Remaining can be nothing, but it can be hypothesis that remaining is nothing but n minus 2 into m. This is our hypothesis. Remaining is n minus 2 into m. Why? Because n is the total number of people and m pairs have already been formed. In this case, for example, m is equal to 1, denoting that 2 people have already been formed, because m pairs, 1 pair of people have formed teams. So 2 people have formed teams. So remaining are n minus 2 into m, the remaining amount of persons. That is equal to, here n is 2 and 2 into 2. So remaining, no persons are remaining. So obviously output is yes, all the people can successfully participate. But now let's look at a harder test case. N equal to 4 here and m equal to 1, meaning that persons 1 and 3 have formed a team. So how many people are remaining in this test case? 4 minus 2 into 2, 4 minus 2 into 1, sorry. N minus 2 into m. N minus 2 into m people are remaining. So 4 minus 2 into 1 is equal to 2 people are remaining. So which are these 2 people? Remember, in this test case, what we are looking, that I highlighted here, n is equal to 4, m equal to 1, and persons 1 and 3 have formed a team among themselves. Persons 2 and 4 are remaining and they can form a team among themselves. So all people can participate. Yes. Now let's look at the next test case here. Here we will look at this test case here where n equal to 5 and m equal to 2. So how many people are remaining? The remaining number of people are nothing but 5 minus 2 into 2. That is nothing but 1 person is remaining. What are the people who have already formed teams? Person 1 and person 2 are a team. Person 4 and person 5 are a team. Now who is the unlucky guy? Person 3 is the unlucky guy because he does not have anyone else to form teams with, and given the problem statement, single member teams are not allowed for this problem statement. So person 3 has poorly no one else, because there are 5 people numbered 1 2 3 4 5. 1 and 2 are in one team, 4 and 5 are in one team. The poor guy 3 has no one else to combine with, so no, all the people cannot participate. Similarly, let's look at this case. Now 5 and 1, n is 5, m is 1. What is the remaining amount of people? 5 minus 2, 3 people are remaining. Is it possible to make teams? Remember, in this test case, 1 and 4 are a team. 1 and 4 are a team now. How many people are remaining? Person number 2, name 2 is remaining, 3 is remaining, 5 is remaining. Now, whatever you do, let's say that you make 2 and 5 form a team, then 3 will be left alone. Let's say you make 3 and 5 form a team, 2 will be left alone. So, no matter what you do, one person will be left alone without being able to form any team. So no, all the people cannot participate. Now if you look at this, you don't even need the data of this, what are the people who are forming the teams. You don't even need this data basically to conclude your answer. How? You know that there are totally n people numbered from n to n, and you also know that m pairs are there, denoting that 2m people have formed the teams. So you know that the remaining amount of people as we discussed is nothing but n minus 2m. So n minus 2m people are left without forming any teams, and we are supposed to find out whether it is possible for them to form teams or not. Now there is a very simple check we will do. We will check if this is even. If this is even, our answer is yes. Otherwise, our output is no. That's it. It's an O of 1 solution. And now you might think, how will this work? It is because, remember, n are the total number of people. 2m people have formed teams. So these are the remaining amount of people. If the remaining amount of people are even, for example, if this remaining amount, let's say, is 4, obviously you can make teams. You can make any, like, you can make this team. This is one valid configuration where all the people can participate. Now let's say the remaining people are 3. So no matter what you do, one person will be left without any team. This is the main crux of the observation, where if the remaining number of people are even, your output is always yes, otherwise no. Hope that part is clear. Now let's look at the code for the approach that we have just discussed. First, we will look at our Python code. In the Python code, it is given that first we input t, and then for every test case we input n and m. How we do that? We take the input, split it by the default delimiter space, and then we map them to an integer. Now for the remaining m cases, we just input %1, %2, denoting that person1 and person2 have already formed teams. Now we know that the remaining amount of people are nothing but n minus 2 into m. We check if the remaining amount of people are even. If the remaining amount of people are even, then our output is yes, otherwise our output is no. That's it. That's the whole code, and here as we see, it's an O1 solution per test case, and we got an AC. Let's move on to the C++ code. The C++ code is pretty much the same thing. For every test case, we import n and m, and then we store the value of m in a copy variable, just so that we can run this while loop that modifies the value of m, and we input %1, %2, basically denoting that person1 and person2 have already formed teams. Then the remaining amount is n minus 2m. We check if that mod 2 is 0, denoting that it's even. We output yes, otherwise no. The only mistake that you can do in this problem is to mess up the bracket sometimes. So if you just add n minus 2m mod 2, that will be a mistake. So just check if it's correctly bracketed, and now you get an AC here also for the C++ code. Hey guys, that was it. Thank you so much for watching this video, and if you haven't yet done this is a gentle reminder to hit that subscribe button. If you're interested in competitive programming and data structures, this channel is a one-stop solution for you. See you in the next video. Bye.